Hello students. So today I will teach you a trick which is a very handy trick to represent a system of linear equations, solve them using elementary row operation. So this is the last part of our programming course where we were dealing with matrices, we are dealing with system of equations, we are dealing with fitting of curves as well as interpolation and extrapolation. So in this last step, we learn to solve problems of solving a set of linear equations using matrix method. So as you know that suppose I have a system of linear equations that look like this, say x plus 3y is equal to 7 and 3x plus 4y is equal to 11. So these kind of equations are something that you know can be represented in terms of matrices, and if you calculate the matrix inverse, right, matrix inverse, then from there you can figure out that what is the solution of this equation. So you can represent this particular equation in terms of a matrix and x and y, right, and that will be given by 7 and 11, right. So this in this way, if you just represent the matrix in terms of a system of a linear system of linear equations in terms of a matrix, then this a if you can inverse it, a inverse, then you can get the solution of this equation, right. So we have learned how to calculate a inverse using numpy. You have also learned that how to do it using a step-by-step method using Python. Today we learn a trick that is called a trick of augmented matrices, or in general it is called Gauss-Jordan method. Gauss-Jordan method of solving system of linear equations. This is also the same method is also handy if you want to calculate the inverse of the matrix, because this is what we do. So that is what we will learn today, the Gauss-Jordan method. So the process begins by first expressing the system as a matrix and then reducing it to an equivalent system by simple row operations. So the process is continued until the solution is obvious from the matrix. The matrix that represents the system is called an augmented matrix, and the arithmetic manipulations that are allowed to do the reduction mostly involves row operations. So here what are the allowed steps that you can do is basically you can swap rows, right, and you can multiply or divide anything, multiply or divide each element of the row by a constant, okay. And the third thing is that you can replace a row by some addition and subtraction of other multiple rows present in the matrix, right. You can do that. So this kind of 3 row operations are allowed. No column operations are allowed, but using this you can calculate both things. You can calculate the inverse of a matrix as well as you can calculate solution of linear equations. So let us just step by step see that how you can solve a system of linear equations, and as well as you can do the matrix inverse. So let us start by this particular system that I have already written the equations. So let us start from these equations. So if you solve these equations in your own, you will see the solutions are x equal to 1 and y equal to 2. So let us see how we can arrive at these solutions using the Gauss-Jordan method. So what is the recipe? The recipe starts obviously by this, that you express the system in terms of a matrix. So how will I write down the matrix? So I will write down something like this, that I will start the matrix 1, 3, 3 and 4, right, and then I will have a line like this and I will write 7, 11, that is these two numbers, right. These two numbers I will write here and I will close the matrix. So this is the augmented matrix for the system. So the augmented matrix for the system, this is called the augmented matrix for the system. So I hope it's obvious that how to write it, the coefficients, coefficient, 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 and then whatever is on the right hand side of the equation, you put that after putting a line, right? So why are we putting a line? Now we will do the row operation and we'll see simply that these two numbers will gradually turn into your solutions, right? So let us see how it goes. So I will start by this. I will start illustrating so that you see that what actually is going on, and then we will solve a problem of 3 cross 3. There I will move a little bit faster. So this is your augmented matrix, right? This is the matrix on which these three kind of operations are allowed, and you can change this matrix. So ignore this part, ignore the other side of the matrix, this part of the matrix for now, and plan that how you can turn this side of the matrix, this part of the matrix, how you can turn that to a diagonal matrix with only 1 on the diagonal. So here and here, in these two positions you need 1, and rest of the elements has to be 0. Whatever operations you feel suitable for that, go ahead and do that. Remember, only row operations are allowed, right? So parallelly, to show you that what is going on, I am writing down the equations on this side just to illustrate that what is going on, okay? So I am writing down the equations on this side. Okay, now let us, you can choose any row operation, right? So I am doing it on my own. So the first thing I am doing is that I am multiplying the first row by -3, that is this first row. So I am multiplying the row number 1 with -3 and adding it to second row, to get my new second row, right? That is my first operation. I want to make this term 0. So one by one you have to target and make them 0. So I am multiplying this row by -3 and adding to this row and putting that as my new row number 2. So row number 1 remains intact, and whatever happens to the rows here, same goes here also. So you put 7 intact, and here I am doing this -3 plus, so -3 plus 3, it becomes 0. Whatever you have here, -3 times that plus 4, so it is -5, right? And same here too, same operation goes here too. So -3 times 7, that is -21, plus 11, that means -10. Okay, hopefully this is clear. This is clear that what happens here. So you just had applied a row operation to make this 0. So now let us see that what happened to the equations for this. For this, after this operation, the equation that you have is basically this, that the first equation remains intact, x plus 3y equal to 7. The second equation, there is no x plus -5y is equal to -10, right? So remember, if you solve this equation, I told you already the solutions are x equal to 1 and y is equal to 2, and you see that we have already moved very close to that with this, right? So we are on the right track. So this is what you have to do. Step by step, you change your elements with row operations such that they become 0. For example, now what should be my strategy? Now say I divide, the straight ahead I divide this by -5 to get this term, make this term equal to 1, right? So the next step obviously is going to be that my matrix becomes 1, 3, 0, 1, division by -5, division by -5, and my augmented matrix becomes 7 and 2, right? So this is done. This equation is also clear. So here I already have x plus 3y equal to 7, but y is equal to 2. That is already there, right? Now comes this term. Now I have to target this one and make it 0. So to make it 0, what do I have to do? I have to multiply this by -3 and add it to that, right? So let us do that. So my first row, row number 1, new row number 1 would be my second row multiplied by -3 and plus row 1. So let us see, if I do that, then what do I get? I get this first, my augmented matrix 1, and this becomes 0, and here you have 0 and 1. But what do you have on the other side? On the other side, what you have is row 2, that is this element, times minus 3, that is minus 6, plus this, so that means 1, right? So you see what happened? So now what are your equations? The first equation is x equal to 1, and the second equation becomes y is equal to 2, and you solve these two equations. So I hope the trick is clear, that how you move from a matrix which had all 4 elements to a diagonal matrix where you only have one sitting there, rest of the elements are 0, and your augmented matrix turns into your solution. So this is Gauss-Jordan method. This is a numerical method by which you can solve the set of linear equations. Now in the same way I can also demonstrate that how you can inverse a matrix, right? Because inverting a matrix will be basically the same thing. In case of inverting a matrix, what you have is basically you create your augmented matrix like this, that suppose you have a matrix, say 2 cross 2 or 3 cross 3, whatever your matrix is, say you have that matrix, and you have the matrix here, right? This matrix you have to invert, and what you start with is that you put this line on the other side, you write the identity matrix of the same dimension, right? So for example, I have a 3 cross 3 matrix. Say I have a 3 cross 3 matrix, and the matrix is 3 0 2 2 0 minus 2 and 0 1 1. This is my matrix, and I have to invert it. I have to find A inverse, right? So this is my matrix. So I will create the augmented matrix such that here I will put the line, and I will write the identity matrix of the same dimension. That means 1 0 0 0 1 0 0 0 1. So this is my augmented matrix. Okay. So once you have this quantity sitting here, my goal would be something like this, that I will try to use similar tricks, addition, division, subtraction, multiplication, swapping, to the rows of this matrix to turn this into the identity matrix. That means as if I am making this my identity matrix. How can I make this my identity matrix? By multiplying it to A inverse, and that means this will also get multiplied with A inverse, leaving this side of the augmented matrix, this side will become my I, while the other side will become A inverse, right? So this is what we target. This is what is our goal, that we make this happen such that your identity matrix turns into A inverse, while your A matrix turns into your identity matrix, right? So again the same rules: swap rows, multiply or divide each element by a constant, or replace a row by adding or subtracting multiple of another rows. You can do that. So here also you see that many elements are already 0. So what we can do is basically try to make the other elements that are present there. Let us try to make the other elements vanish and see that how it can go. So here let me start by the first, what should be the first operation? Anything, you can choose it accordingly. For example, let me just target this, right? If I target this, then basically if I add this row and this row and put it there as my new R1, so my R1 prime will be R1 plus R2, then this one would become 0. So my target is to make this entire thing as 1 1 1, and the same operations you have to apply here also, right? So that is your target. That means the first step would be when you get the element to be 5 0 0 2 0 minus 2 and 0 1 1. That would be your first step, right? And similarly, at the same time, your augmented matrix would also change, and it would become 1 1 0 0 1 0 0 0 1, right? So this is how it goes. Then you divide it by 5, the first row, to make it 1 0 0, to make this row as 1 0 0. So you divide it by 5, immediately it becomes 0.2, 0.20. So go on doing this continuously until you reach that your first matrix becomes this, rest of them are zeros, and that same operations will turn this matrix into your A inverse, right? So I hope the method is clear to you. The method can be used for both the purposes. Also for 3 cross 3 matrices, just take a set of equations and try to solve it and see if you can achieve the solutions by this row operation method, the Gauss-Jordan method. It's a very powerful numerical technique, because many a times calculating inverses becomes a bit difficult, and you have obviously encountered that kind of a situation. In those situations where calculating inverse is not that straightforward, this is a very good numerical technique that helps you through, right? So this is all about Gauss-Jordan method. I will stop here for today. This more or less concludes our syllabus for this course. We can meet once again for an extra class for doubt discussion about the entire syllabus. So see you in that class and concluding the syllabus for now. Bye bye.